Yes, students of class 11. Now, chapter number 1 in chemistry. Chapter name, some basic concept of chemistry. Now, in this chapter, topics are, we have covered chemistry, general introduction of chemistry, importance and scope of chemistry, nature of matter. Now, today we will study law of chemical combination. Law number 2. First law was the law of conservation of mass. We have studied in the previous video part 2. Okay. Now see, in law number 2, this law name is law of definite proportion or law of constant composition. Okay. So in this law we will take this law we have divided in 4 sections. First, statement of this law or examples and experimental verification in brief. Then we will take numerical based on it, and then limitations. Okay, so let's take the statement. Now see, what is the law of definite proportion? Law of definite proportions. Okay, or second, law of constant composition. So it is very simple, constant composition. Okay, see, according to this law, a chemical compound always consists of the same element combined together in the same ratio. Okay, so see, a chemical compound, these are the original statement of the scientist Louis Proust. Okay, so a chemical compound always consists, okay, of the same elements combined together, okay, in the same ratio, irrespective of the method of preparation, irrespective of the method of the preparation or the source from where it is taken, So law is very simple. Consists same number of elements combined together in the same ratio, irrespective of the method of the preparation, right, or the source from where it is taken. So this is a law. Now see, this law was experimentally verified by scientist Stas, and he prepared carbon dioxide in different methods. So see, this is a law. For example, I am taking different method of this law to see this. Now we are going to examples. Simple. So according to scientist, this law was verified by scientist Stas. Okay, Stas, it was obtained CO2 gas in different methods. So what are the different methods? See, number 1 method is calcium carbonate heat CaO plus CO2. Second, sodium bicarbonate is heating sodium carbon dioxide carbonate plus H2O. Okay, so this is a gas. Now third, burning of carbon CO2. Fourth, calcium carbonate reacts with dilute HCl CaCl2 H2O plus CO2. Okay, so there are 4 methods to obtain this CO2. Okay, so these are the four methods. So the source from where, okay, the source, there are four, and the CO2 is coming. Now we see CO2 ratio is a constant composition, very simple, 12:32. Now simple is 4 3 are 12, 4 8 are 32. So this is a fixed composition, right? So whatever the sample of carbon dioxide is taken, it is observed that carbon and oxygen are always combined in the ratio 12:32, 3:8. So this is a yes. Now next, okay, so this is a law. Example. Now we are taking up next numerical section. Okay, so children, see what is the numerical of this. Now numerical is very simple. Now 1.3, see the numerical, 1.375 gram of copper oxide on reduction, it gives, okay, on reduction it gives hydrogen, on reduction it gives reduction in hydrogen, it gives, the value is very 1.089 gram of copper, right? So gram of copper. In second experiment, okay, 1.179 gram, 1.179 gram of metallic copper produced, right? 1.467 of copper oxide, so that this data is valid for this law of definite proportion. Yes, so this we have to. Now we are going to solve very simple. Here is a simple student, mathematical value is here and here. See, it is clearly saying copper oxide on reduction. The reduction means addition of hydrogen, children. So first you will take copper oxide plus hydrogen, metallic copper and water. Okay, see, so case number 1, experiment number 1. This is experiment number 1. See, 1.375 copper oxide, write this value, 1.375 gram of copper oxide, and it is gives this 1.098 gram copper. Now in second experiment, this is metallic copper, means for metallic copper we will write here, the value is 1.17 gram, 1.17 gram this, okay, of metallic copper. Now is producing 1.476 gram of this. So children, it is very simple. 1.17, this is a 9, sorry, 9. So 1.1179 gram. So this is a data for experiment number 2. Now very simple. In both the case number 1, first we will calculate the percentage of copper. Okay. So at everywhere at the end we will prove that both the sample contains same composition. Okay. So first calculate the percentage of copper. So how would you calculate the percentage of copper? Mass of copper upon mass of copper oxide into 100. So first case, that is a 1.098 upon 1.375 gram into 100. Okay, same case is here, percentage of copper Same case. Now 1.179 upon 1.476 into 100. Okay, so children, very simple. When you will divide this, so very close value will come, 79.86% will come, and here will come 79 point suppose 89 or 86. So here will become 79.89. so this is a mathematical, so simple mathematics is calculation is there, so this value will come. So in both the experiment, case 1 and case 2, okay, percentage of copper is 79.86. second experiment, percent of copper is 79.89. so there is no big difference. Okay, so children, so is this way, this there, in this way percentage is the same. Fixed composition is fixed as said in the law. So this data is valid for this law, and this law is law of definite proportion or law of constant composition. So children, so this it was again I am telling you, yes, problem is very simple. Two cases given, two experiment is given. In first experiment, calculate the percentage of copper. Formula very simple: mass of copper upon mass of metallic oxide, mass of metal upon mass of metallic oxide into 100. Okay, so same formula we will use in the case number 2, experiment 2. Then we will compare this data. If the value is coming same, so it means this law is obeying, this law is valid for this law. Now next topic comes, the last topic of this video, that is a limitation of this. So limitation we told you were number 1, you know, law is law of definite proportion is not hold good on non-stoichiometric compound. So non-stoichiometric compound means non-stoichiometric means they have no fixed composition. All right, so let's see the limitations of this law, children. So first non, and second is isotopes. Okay, see, and we are taking example. Okay, so limitation of this law is law of constant composition. The first law is not applicable on non-stoichiometric compounds. Okay, second, okay, this is one limitation. Second case limitation is, right, by using different isotopes. Let's take example of different isotopes. See, hydrogen of isotopes of hydrogen. So one is H2O, second is D2O. So hydrogen means isotopes of same element, hydrogen and deuterium. See the ratio, hydrogen 2 is to 16, here 4 is to 16. So in this case, make it simple, 1 is to 8, here 1 is to 8, 1 is to 4 ratio. So ratio is not fixed, ratio is not coming fixed. This is okay, so these are the isotopes, children. So different isotopes of same element, so we can write different isotopes of same elements give different mass ratio, means different isotopes means hydrogen and deuterium, they are different, that is why, and different mass ratio is this 1 is to 8, and this is a mass ratio is different coming between the combining of elements, between the combining of element. So children, two drawbacks. We are reporting here, explaining it, talking about two drawbacks. Okay. So number one, number two. So children, in this way, we have covered this law. Is definite proportion is also a very important law. Okay. So first we have explained the statement of this law, and then examples, experimental verification, and numerical. One numerical we have solved, and then next limitation. All right, children. So in this way we have over this video now, and we will study next law in next video. Okay, children. See you again. Goodbye.